Hi, everyone. This class is about how we built one of the largest bird parks in Asia, officially called Bird Paradise, using a digital twin in a unique way to minimize construction issues and environmental impacts, and more. Quick introduction about ourselves. My name is Shusaku Kawamoto. I am a General Manager of the Digital Transformation Division at Obayashi Japan headquarters and an Innovation Lead of the Asia Digital Lab in Singapore. I've been promoting open innovation at Obayashi, leveraging our global network.
My name is Patrick Chia. I'm the Project Director of Bird Paradise and the Director of Obayashi Corporation. Today, we are excited to take you on this fantastic journey to Bird Paradise.
Hi, my name is Paul Andaya. I'm a BIM Manager of Obayashi, Singapore. My pleasure to speak at Autodesk University.
Before we start, let us quickly introduce our company.
Obayashi組は日本の産業が近代化の波に乗り出した1892年に創業し、今年で131年の歴史がある総合建設会社です。1914年に開業した東京中央停車場では高い施工技術が評価され、その DNA は今日へと受け継がれています。大林組は日本、北米、アジアを中心に世界各地で事業を展開しています。16の国と地域に拠点を持ち、136のグループ会社とネットワークを構築しています。2021年、大林組は Make Beyond 作るを開くというスローガンを掲げました。ものづくりで培ってきた力を時代に合わせて発展させ、新しい領域を開いていくという思いを込めています。来たる2050年のあるべき姿に向かって大林グループは動き出しています。
Make beyond transcending the art and science of making of things. These words are an expression of Obayashi Group's desire for the future to advance the technology and knowledge of craftsmanship we have cultivated over our history towards a new level that is in line with the current times and achieve growth that goes beyond the existing business framework. To contribute to realizing a sustainable society as stated in the Obayashi philosophy, the Obayashi Group outlines its 2050 vision in the Obayashi Sustainability Vision 2050. Towards the realization of sustainability of the planet, society, and people, the Obayashi Group will continue to take on the challenge of ceaseless transformation driven by talent and innovation to keep providing a variety of solutions for the sustainability of places where we reside, spaces, cities, and the environment.
What we are going to talk about is how we achieved a digital twin and single source of truth among various stakeholders in this large and complex project. We will be introducing specific use cases of Autodesk solutions covering these three topics. Hopefully, at the end of this class, we will have a better understanding of how to utilize digital tools to collaborate towards our sustainability and productivity goals. So let's move to today's main topic. I will hand over to our project director, Patrick.
Hi, this is Patrick again. Located between Mandai Wildlife Reserve in Singapore, Bird Paradise is the largest bird park in Asia. It replicates different habitats from around the world. Over the past 5 years, we have faced unprecedented challenges that involve the construction of a large-scale project that required integration of many different stakeholders towards the same project goal, as well as the pandemic-19 pandemic. We have created a short introduction video. Let's take a look at it.
Located in Singapore, Bird Paradise is a 17-hectare bird park that soft opened in May this year. It is the largest bird park in Asia. The park is home to 3,500 birds from over 400 species with 10 themed zones replicating different habitats from around the world. Visitors can explore 8 walk-in aviaries and immerse themselves in unique habitats at the 17-hectare bird paradise. We can also enjoy cascading waterfalls at the West Node or take a walk in surroundings inspired by the Australian outback. The wildlife park, designed to bring visitors close to stunning bird species, will be a platform for the organization to further its education and conservation work in the region.
Well, the construction of the Mandai Bird Paradise project is a pretty challenging project for the contractors. Firstly, because the location of the site is in close proximity to where the reservoir and the water catchment reserve is. Secondly, we have a very stringent environmental impact assessment that has been done. So Obayashi as the contractor has to comply very strictly to the constraints of the report. For example, working hours, the type of machinery they can bring on site to manage the noise level. Thirdly, the need to preserve and protect the rich biodiversity in the area. For example, building tree protection zone to make sure that not too many trees are removed from the existing site. And then ensuring that there is wildlife connectivity throughout the construction period. In other words, wildlife can move in and around the construction area without hindrances, and also not to disrupt animal welfare in the night. So working hours are also constrained. I think Obayashi in their own planning has done a marvelous job, especially with the use of advanced digital technology to map out the large aviaries they are expected to build, and there are 8 of them, as well as the iconic bird entrance roof, which was very challenging.
Obayashi has been dedicatedly working with the idea of balancing nature preservation and new landscape realization, while ensuring that stakeholders are fully satisfied and producing high-quality results within the time frame. To achieve this, we have utilized the best digital technologies, and we are pleased to see that the client has been satisfied with our final result. I'm deeply proud of our team's hard work, and I thank you for letting us to be a part of this exciting journey. I sincerely hope that Bird Paradise will give everyone in the world dreams, hope, and inspiration. Thank you for your attention, and I hope you enjoy the rest of our presentation.
Let's dive deeper into the challenges and solutions. Nature first is the most representative key phrase of this project, with a strike harmonious balance between conservation of nature, biodiversity, and the construction of large complex structures within the same time frame. We also had to collaborate with the stakeholders from different disciplines, all working towards a shared objective. Also needed to maintain the original natural topography as much as possible. On top of that, we needed to integrate feature elements that mimic nature and possesses a very organic design expression. There were no options to adopt standardization nor traditional 2D drawings. Without an integrated BIM model for the design, it would be difficult, if not impossible, to manage the design development. Work sequencing and site verification were also increasingly difficult due to this cascading complexity of the project. That's why we needed to address the constructability issues and minimize environmental impact through the virtual design and construction process. To overcome these challenges, we utilize software such as Revit and Navisworks during the virtual design and construction phase. However, the real challenge was how to ensure the alignment between the real and digital worlds. This was not an easy task and can only be achieved through collaboration of all project stakeholders. Only then can digital data be considered as the single source of truth among stakeholders so that digital twin can be fully utilized. Let's take a look at what we did. First, we began by using a drone or 3D scanner to capture reality and generate the necessary point cloud data. Second, we integrated this data with BIM and coordinated the design, model, and construction processes. From there, the stakeholders could then make important decisions based on this digital twin. As a result, we could effectively implement the best practices on site.
Thank you, Patrick. Now it's time to look at our use cases and sequence. First is about digital modeling of nature. Let me begin with this question. How do you create a digital twin that accurately replicates each individual tree as well as this vast and rolling terrain? Well, we use drone to capture the site's topological features. All the collected data was processed through Pix4D and Revit to generate various outputs such as point clouds, orthomosaic images, toposurface models, and 3D contour lines, which were useful for our subsequent tasks. Now let's look into our first use case. How will you utilize the digital twin to minimize excavation and disposal of soil? Traditional land survey methods are not sufficient for this massive development. Instead, we employed drone to map the entire site and generate a comprehensive toposurface model. This allowed us to analyze the level differences between the current state and the proposed levels using Revit and Dynamo. By doing this, we were able to optimize the movement of soil from excavation areas to backfill areas, minimizing both excavation and soil disposal. As a result, one of the outcomes of these 8 aviaries we have built is this beautiful terraced rice field landscape. Let's consider this next case. So how we use technology in the preservation of heritage trees and water reservoir during construction period? We took an additional step by superimposing site utilization drawings onto orthomosaic images generated from drone mapping to closely monitor site execution and ensure that it has been maintained in its natural state. Without a digital twin, overseeing the environmental impact of each construction phase on nature would be challenging. Now let's talk about identifying and solving the challenges by integrating nature and buildings. So how we use the digital twin to preserve existing trees and terrains? By combining point clouds within federated beam models in Navisworks, we were able to visualize the complete form of the project. We ensured that the design prioritized the trees with meticulous effort. However, the digital twin helped us efficiently identify several important issues and resolve them before construction without disrupting these protected areas. This includes wall theming coordination process, which I will run through in the next slide. So this unique rock design was first presented through a scaled clay model. Subsequently, it was converted into a 3D surface mesh using 3D laser scanner and was optimized for seamless integration with the beam models, forming the foundation of our digital twin. This became a valuable tool for our client, consultants, and subcontractors. With this, we were able to evaluate design accuracy, ensure smooth design coordination, create detailed and schematic drawings, and accurately calculate necessary quantities. Looking at this example, this is a complex rockwork surface submerged inside an acrylic tank. Utilizing the digital twin is a game changer in coordinating structural support and interfacing among various trades such as MEP systems. We fully coordinated all models and achieved precise positioning of all enclosed services within rockwork surface. Thereafter, these data serve as a single source of truth for our fabrication and shop drawings across all disciplines, including architectural, structural, and MEP. As a result, you can see this breathtaking outcome. Now that we have completely resolved all the challenges, we proceeded with the actual field implementation. Therefore, our journey with digital twin continued. In the following slides, I will introduce two remarkable cases. Let's start with the walkthrough aviaries. So how we use digital twin to construct such complex walkthrough aviaries. Imagine a space merging nature and engineering with 8 massive walkthrough aviaries. And backing this vision are numerous towering steel columns, each reaching the height of an 8-story building and carrying substantial loads. These structures are covered by a massive mesh, forming an expansive sanctuary for birds to fly freely. The digital twin played a significant role in shop drawing preparation, fabrication, and construction management of these complex and non-uniform structures. Let's explore this further in the next slide. Coordinating the design and installation of these tall, heavy, and inclined columns and footings is way more than complicated. It's not just two-dimensional, but it requires positioning and orientation along multiple axes. Through Navisworks, we ran simulations to coordinate this complex structure, detecting issues in virtual space. Once optimized, construction drawings are generated from this single source of truth data. Integrating BIM with engineering practices offers better accuracy in collaboration, ensuring the project aligns with its specifications. Now let's talk about Penguin Cove. For this 3,000 square meter Penguin exhibit, which includes 23 massive acrylic panels, weighing up to 10 tons each, digital twin played a major role. With this approach, mirroring every detail of the temporary and permanent structure allowed us to foresee challenges and streamline workflows. It's more than just a proactive approach. It's a strategy ensuring efficiency, safety, and optimal resource utilization. And lastly, the digital twin was also utilized as a single source of truth in on-site inspections. We use optical and laser scanning devices, depending on the type of inspections, to compare the results with the digital twin accurately. This ensures that they meet the required accuracy and quality standards. Nevertheless, this is not the end of this journey yet. Our true main goal is achieving the collaboration towards shared goal among all the stakeholders. Only through tremendous efforts of all involved parties, the digital twin became as a reliable base and could bring us back to the idea of coexistence. In other words, this is the ultimate form of a single source of truth. Thank you, and back to you, Patrick.
In conclusion, we discussed how we successfully implemented a digital twin and established a single source of truth among various stakeholders in this large and complex project. We also covered the specific use cases of the digital twin, including digital modeling, data integration, and best practices on site. The tools we utilized, including Revit, Navisworks, and Dynamo, to name a few, have revolutionized our ability to digitally capture the complexities of nature while empowering us to make informed and strategic decisions, to also ensure both sustainability and productivity. Today, we live in an era characterized by constant change and deterioration of nature. At Obayashi Corporation, we are committed to the pursuit of nature preservation and economic rationality. To achieve these goals, digital solutions and Autodesk products will play an increasingly important role in the future. We, as Obayashi Corporation, aim to grow as a company that successfully continue to harness these digital solutions through continuous innovation. To conclude our presentation, we have created a 2-minute short video that summarizes the successful results of the project. Thank you very much for your attention.
Effective communication was key. Working closely with architect and design engineer, we used digital twin to identify potential crashes and refine our construction sequence in the project. This practice doesn't only save our time, but ultimately contribute to the overall sustainability of the project.
Building information modeling has greatly assisted us engineers in the construction field. It offers a digital hub where all parties can collaborate, consistently providing the latest model and information, resulting in well-coordinated design and fewer conflicts. Due to the high complexity of the project, it was crucial to have a single source of truth data that everyone could agree on, both for design and construction. That way, we could all get our work done way faster and easier. Therefore, it is important to be implemented in the project.
Then I want to congratulate Obayashi as we recently opened the park. They have done a fantastic job in terms of a disciplined approach to balance construction, biodiversity, and animal welfare. Congratulations to Obayashi.